Hello everyone, my name is Jim Garrity. Welcome to this video. It's the second in the series showing the rewiring of a stator of a vintage single-phase motor. In part 1 you remember the original motor of my compressor down there in the corner. It had an integral pressed steel foot that had fractured. A friend gave me an old 2 horsepower motor with a cast steel foot. A quick replacement, he said. 2-minute job. Well, that's what we thought. But then I found that the insulation on all the internal wiring of the stator of that motor had started to crumble away. Well, all hopes of a quick turnaround disappeared. I can hear you ask, why didn't I just weld the foot of the original motor? It certainly would have been the quickest way to get the compressor working again. But the problem there is, the motor that my friend had given me, I'd sort of used this as an excuse to get it back on the road again, and now it would probably end up at the recycle centre. Well, I wanted to save that motor, and I'd never rewired a motor stator before, so I thought, well, it's a bit of a challenge, let's give it a go. So we pick up the story on the wiring bench at the back of the workshop. The motor is completely disassembled, and the rotting wires are hanging out from the stator. It's now time to address the wires coming out the back of the stator. All 4 of these wires need to be replaced. 1, 2, 3, 4. But I've got to be careful because I mustn't lose which wire goes to where. Now, I'm going to be replacing them with just a black wire because that's the only wire that I have on hand. But I'm going to use coloured sleeves so I know which wire goes where. Now, the 2 wires going to the start windings are these 2 here, and you notice that one has a sleeve on the end, on top of the insulation, the other one hasn't. And on the run windings, which are here, we have one with a sleeve and one without a sleeve. Now that's important because if you get them the wrong way round, it won't start correctly. So I've got to make sure I get the wires the right way round. I also need them the correct length as well, so I'll be using these lengths. In fact, I'm going to measure the lengths before I get stuck into it. To get down to the connections where these wires go on the end of the windings, I'm going to have to cut off this lacing cord. Now, I have lacing cord, which I could replace it with, but I'm a little bit worried that I don't know the working temperature of the lacing cord that I have, and these will get warm, not excessively, I hope, but they will get warm. So what I've decided to use instead are PTFE cable ties. Now, these particular PTFE cable ties are meant for high temperature situations and actually have a stainless steel barb in here which does the clipping instead of the normal plastic clip in there. So that's what I'm going to be using for holding all the windings and the wiring together. I've released these 3 wires from this side of the stator. Now I think the stator must have been vacuum impregnated or at least dipped because everything is very well stuck together. Even the lacing cord, it didn't want to come off. Every loop I've had to tease out with a small pair of relay pliers, and then the wires themselves were stuck in, but they're out now. So the next job is to cut back the sleeving, which is protecting the wire and the joint, and then we can connect our new wires onto that. I've just made off the first joint. You can see it here. The black wire is the new wire which I put on. The enamel wires on top are what are leading from the stator. The joint here in the centre. Now the original joint was a welded joint. I haven't got any facilities to weld copper wire, but I can make a very strong joint, and that's what I've done here. It's actually a lap joint, so the new wire is lapped on top of the 2 enamelled wires. All the enamelling has been removed, so the solder flows nicely over it. But once you put the 2 pieces of wire together, in fact there are 3 pieces of wire because there's 2 enamel wires, you then bind them together with 24 gauge tin copper wire. You make that nice and tight. Once it's tight, you snip it off at each end, then using the flat relay pliers just push the ends in to make it round. You don't crush the joint, you just push it in so there's no sharp edges sticking out, and then bring the iron up and solder it, and you end up with a very strong, very durable joint. Now I'm going to cover this with heat shrink, and I'm putting red heat shrink on. The original wire colour here was red with a red sleeve. That's this one here. So this red piece of heat shrink will remind me that it's the red wire with the red sleeve. All 4 wires are connected now. I've identified the ends, so I'm not going to forget which wire is which. Next thing to do is get the tie wraps and bind these wires in with the stator wiring to make it all nice and rigid. This is the back plate of the motor. We can start assembling now. The switch, which will fit here, is held in place by 2 screws, which are just here. The back plate has all been cleaned up now. I've cleaned out the bearing, put a little bit of oil on the felt, and I'll be oiling that proper once we get the motor back together. I'm a great one for putting anti-seize grease on threads, and I tend to put it on the screws and into the threaded holes. If you put it just on one side, if you put it just on the screw, then as you screw the screw into the thread, then I can't help but think that it will dry out on the way down. So I always put a little bit on the inside of the threads as well as on the screws. And the switch goes around this way, and now I'm not going to put the temperature sensor in. The one that I have is broken, so it's going to be put together first of all with no temperature sensor, and it's easy enough to pop the back off, so I can always put one in later once I've proven that the motor does work. Right, they are nice and tight. The next thing will be the wiring. Right, so the first wire to connect is this wire from Stator, and it needs to go onto that connection there. So this is a wire which needs to connect onto that terminal, and I'm going to use an eyelet like this. Now this is a crimp eyelet, and I don't like using crimps in places where it's going to get dirty and possibly damp. So what I do is I pull the sleeve off the back, just give it a twist like that. Now I'm going to solder this onto the end of the wire here, and then I'm going to put in cover it with heat shrink. Now I've already cut off a piece of heat shrink that's here, so I'll put that on the wire now before I go ahead. We'll strip the wire like that, and then the wire, as it happens, the wire that I'm using fits quite nicely into the crimp bucket there. And now what I do is solder it. So if I hold the wire like that. Oops. So that's the wire soldered on. We can now take the sleeve over the solder bucket. Where's it gone? There it is. Over the solder bucket like that, and then using the heat gun, shrink it down. I found 2 washers which are here. I just put them on the stud, and I'm going to put the nut on there because I'm not going to connect this at the moment. It's just dawned on me that I need to put the connection block in. And the last thing I want is this connected to the stator whilst I do that. So I'm going to put this in first, and then I'll come back and put this wire on later on. Even though there's nothing wrong with this wire, I could not change it. I've changed all the other wires, so this has now been swapped out for this one, which I've just finished off. So we've got a brand new wire for this. All the wires in the back of the motor have now been changed, or they will be once I finish off this rear panel. And the wiring's complete. We have 3 wires on this side of the stator, all with their connections on. The one wire on this side is complete with its connection on. The back plate is wired with its single wire there. The wire here will be it will be connected to the terminal there on the centrifugal switch, and then the back plate will be turned over and nestled on top of the stator, tapped into position, and then these connections will be made up through this hole here onto the terminal strip, and that's the next job. We are ready for final assembly. The back plate is now on the motor. The stator is ready to go. Everything's been cleaned out. The rotor has been cleaned, and the bearing surfaces have been cleaned off, and the front plate of the motor is ready to go in, and also the tie bars have all been cleaned up, and anti-seize put on their threads. So everything's ready to go. Last thing I need to do is just squirt some oil in the journals, make sure they're nicely lubricated, and also the journals on here, because remember, this hasn't got bearings in, this has got bushers. And so we're going to need oil on there, that goes in the back, oil on the front, on with the front, in with the tie rods. And then I can start sorting out the power to it. The motor is assembled once again. Look at it. I'm going to be painting it once I've convinced myself that it works, or once it convinced me that it's going to work. The last thing I've got to do is put oil in the journals. I put a little bit of oil on when I assembled them, but I just can put a squirt more in the 2 oiling buckets down here. You can hear it click. There's one, and the same on the other end. They were very dry, and I don't think it'd been oiled. I know it hasn't been oiled for 2 years because it sat in the garage. But anyway, I better get the mains cable made up, and then we can test it. The motor is all together. The wiring is in the motor, and now it's time to plug it in. Right. Now this is the first time I've ever run this motor. If it doesn't work, I'll fix it, turn it on again, film it and say, this is the first time I've ever turned this motor on. Anyway, let's see what happens. It works! It works! Woohoo! It doesn't sound too bad either. Well, I'm pleased. Now I need to know the RPM of the motor. I know it's clockwise. That's good, because the other one was clockwise, so I know it's going to turn the compressor the right way round. I've just got to find out what the RPM is now, and then sort out the gearing, or the pulleying of the motor. Motor's been running for 20 minutes now. The stator is getting warm. I can still keep my hand on it. The start capacitor is still cold, so that shows that the switch is working. If that was still in circuit, that'd be getting quite warm. So the motor is warm, the bearings are cooler than the stator. Yep, that's still cool. I've checked it once before already. And it's running. Woohoo! So we now need to measure the RPM of this motor. Should I go grab my digital rev counter? No, I don't need to do that because I have one of these. And this is a Smith's mechanical RPM meter. Look at that baby. Now then, this I've had for years and years. In fact, I've had it so long I can't remember who I originally stole it off of. Right, what it is a meter here that shows the RPM. This shaft here has got to be turned, and as that turns it measures the RPM, or it displays the RPM on the meter here. There's 3 ranges: 0 to 400, 0 to 2000 and 0 to 10,000 RPM. You always start it on the highest RPM if you don't know the rev of the thing you're going to check. Now this has got to make a good non-slip connection to the shaft, and you do that with one of these. This is a brand new rubber, so that's rubber, and this clips onto the shaft. As it happens, I've never used that one because it's brand new. I've always used this one, which I think was the original one. And this one is a little bit worn at the end, and I want to keep the other one for best. Right, so that goes on there. Now we need to start the motor. We push this in on the end of the shaft, and then once it gets up to speed we can then press the lock and then read off what it says. Now the motor that's on the compressor at the moment is 1425 RPM, so I'm hoping this is going to be similar. Right, let's turn it on. Oh, did you see that? Just started, no problem at all. Right, so we now push, and you've got to push fairly hard because you don't want any slippage. We press lock. We're on the 10,000 display. Now 10,000 is in red, which is around here, and that is reading about 1500. So what we can do is unlock it, go down to the 2000 RPM range, and now we give it another go. And that shows we're on the 2000 RPM range. That is the black round here, and we are 1450. So it's 1450 RPM, which probably means it's a 1425 RPM because it's not under load. It's going faster than it would do normally. So this is the same RPM and the same direction as the motor that's on the compressor already. Well, that's good, isn't it? Time to give the motor a coat of paint, and I looked on the shelf and I found some old hammerite. Look at that, silver grey hammerite. Here's the lid, 1996, 24 years ago. Haven't used much. I gave it a good stir and it's looking silver, smells alright, so I'm going to give it a go. The paint has dried nicely overnight. There's not too many runs on it. My compressor is an Ingersoll Rand Model B. I checked on the internet and found some technical information about it, and that showed that its operating range was anywhere between 575 to 990 RPM. This is the original motor with its original pulley. The diameter of that is 119 millimeters. The compressor pulley diameter is 158. When you do the maths on that, it turns out that the compressor is being run at 1073.8 RPM. Probably a little bit slower because this 1 horsepower motor would slow down a bit, but it's still over what it shows in the technical books. Well, the new motor, that pulley is 158 as well, which means that would run it 1-to-1. So this big motor using that pulley would try and run the compressor at 1425, which is too much. So I checked on the internet again and did a search for new pulleys, and I come up with a place called Bearings Boy, and look what I found. Now, I did the maths before I rang them up and found a good size would be 100 millimeters. And if I've got a 100 millimeter pulley on the motor, that works out to 901 RPM at the compressor, which is well within the 990 that they say it can run to. So I give them a ring, made an order, and it arrived. I was actually quite surprised that in total, with all the VAT and delivery, it only came to £20 and 27p. I'm really quite keen to get the pulley on the motor and see how the compressor runs. The pulley fits like a glove. It went on very nicely. They say in the instructions don't lubricate the taper inside, but do lubricate the 2 screws that go in, and then tighten the screws to 20 Newton meters on this particular model. Right, now all I've got to do is lift this huge weight and try and get it on top of the compressor. This is where the motor has to mount. I've cleaned off all the surfaces. I took the 2 rails off, cleaned them up, put them back on, and they're now in the correct position, I hope. So the foot of the motor will fit in these. They're 137 millimeters apart in the centers. They are in line with the pulley from the compressor and also in line with the top of the reservoir. So all I need to do now is try and pick up that huge motor and get it here. We're actually underneath the worktop here. This is my wash tank. So I've got to think of some way of picking that motor up and then sliding it in under here. Well, I have some plastic boxes. Hopefully they're going to be strong enough. I've put a piece of wood across the top to spread the load over both the edges. Plank on top. Now the idea is to plop the motor on there and then slide it back without it sliding off of this and the whole lot collapsing. Woohoo, wish me luck. Well, there was a little bit of creaking, mainly from my back, but we managed to get the motor on. All I need to do now is just push it in and settle it on top of those rails. Well, that's been a little bit of a struggle, and oh no, I've even made a hole in my glove. Right, now I've got to get the piece of wood out and keep the motor in. I don't want that landing on in my lap. Out. Right, motor's down on the rails. Slide it round, and of course the belt has to fit as well. Now the power's off from the compressor. I've actually pulled the plug out, so it's completely disconnected, and the wires are dangling here because I've got to connect that up later on. Connect the motor up later on once I get the motor in the correct position. The belt is on the compressor and it's now on the motor. Right, and now I have to get the new screws, which are over here. The screws are a bit of a mismatch. The person who had it before me obviously changed the motor. The rails are held in, the rear rail is held in by 2 M10 bolts through the top of the reservoir here, or this cover that's welded to the top of the reservoir. The front rail, that has 2 3/8 Whitworth bolts on, and the captive nuts that sit in the rails, they're also M10s. So I have the M10 bolts here. Now I'm using socket-headed bolts on these because they're the only bolts that I had that was the correct length, plus they're going to be nicer to do up. I have a penny washer to go on top of the motor, and then another washer to go on the bolt. So we've got washer through the hole of the motor into the captive nut. Now this is going to take a little bit of time to try and work out where all these captive nuts are and get them in line and then screw these in. So I think I'll bring you back once that's done. The motor is in position and all tight. I can't check the V-belt alignment, so the 2 pulleys. So what I'm doing is holding a lamp up against the side of the compressor and the motor, and then holding the camera at the back, moving it around, hoping that I can get a good view to see if the alignment is correct. Well, you can see it. What's it like? The V-belt alignment is okay. I'm quite pleased with that. Everything is now tightened up. We've got the 2 rails tightened up at this end. There's 2 of the securing screws for the motor. The other 2 are at this end. The last thing to do now really is to wire up the motor. The motor is wired and it's plugged into its own socket on the wall in there. All I need to do now is turn the power onto that socket. And this is the switch that powers up that special socket just for the compressor. Are you ready? 3, 2, 1. Oh. Whoa. Well, it sounds all right. The reservoir is now at 95 psi. The pressure switch has just switched the motor off and the compressor as well. And it's taken 8 minutes to fill that big reservoir up to 95 psi. Well, I'm pleased. The motor in the compressor is working very nicely, and once again I've compressed air in the workshop. I also have the old 1 horsepower motor. Now I know that foot is broken and that needs a little bit of repair, but the motor itself is good, and I've got that just here. In fact, it's on the floor just here. Could you do something like this? Of course you can. And with that, this video is at an end. Take care, everybody. See you next time. Could you do something like this? Of course you can.